All right. Thank you, everybody. This is the March 2026 installment of the Microsoft Data Platform Continuity Virtual Group. With me today is the man, the myth, the legend, Thomas T.G. Grohser. This is Season 2, Episode 2 of what we're calling the SQL Server Truncated Icosahedron table. Today is just another one of those topics that is not glamorous, but absolutely essential to this stuff. It is about recoverability through backups and restores. And with that, go for it.
Yeah. Okay. Well, thank you, David, for the intro. I'll try my best. And I apologize up front. This time I will change the format a little bit because I need to share a few screenshots, because it's really hard to explain certain things without seeing the diagram or the table that explains it, in that area. And yeah, so I've thanks. Backup and recovery. It's, I think, the number one thing that every DBA has to do. And instead of over the years it getting better, what I see in the industry, it's getting worse. I mean, there's some places that have decent backup, don't get me wrong, but more and more places don't have actual backups anymore, or try to save so much money that it's it almost becomes a check mark for audit that they have backups, but they don't actually do backups anymore. And that will end catastrophic for some companies at some day, and hopefully then anything is. So the biggest problem I see is people don't understand what a backup is. And over the years, I found one definition that I went by all my life and never went wrong with is a backup is an independent copy of your data that can be used to restore your databases in case of a system failure, data corruption, or data loss. And the key word in that whole sentence is the word independent. Yeah. The problem is that all modern backup solutions that try to save you money or save you time or accelerate stuff or something like this, they all don't provide an independent copy. They're all based on some storage solution. Like I almost went berserk when in SQL 2022, Microsoft offered that interface to do your own snapshot backups, because a snapshot is not a backup, because you rely on the original data. When you take a database snapshot on your storage system, and for whatever reason, your original data gets corrupted, your backup is corrupted as well because it points back to your original data. The same goes for every backup solution that uses deduplication. You want as many copies of your data. What does deduplication do? It reduces your backups to a single copy. Every database has large portions that never change. Yeah, like in every database, you have the metadata, how the tables look like. They change 2, 3 times a year on larger applications because you're not rolling out every day a new version. So whenever for like 6 months you take backups and your metadata of your tables doesn't change. So the backup system has a single copy of it. If that fails for any reason, the thing is, and even the most expensive deduplication system can fail. Yeah, they provide statistics that they have 6, 7, 8 nines of availability and they never fail. That means that hundreds of their systems they sold failed. Because when they sold 1 million storage systems and they give you 5 nines availability means that 100 of them died. And it's if they don't guarantee 100, it means the system fails because they're putting that out. One of the storage vendors even puts it as a live counter based on their cloud-based management software, the availability of the system. And it's still not 100. So that means the system actually registered system that failed. So this can happen. So the problem is most people don't have the independent copies. Yeah. And even if a storage array says, okay, we're not doing snapshots, we're doing what they call clones, which is basically they quickly take a snapshot and then backfill the snapshot with a copy of the actual data. It's still on the same storage array. It might still end up on the same hard drive because you have, in modern storage systems, you have no control over which hard drive has which data. It's all not AI, but automatically managed. Yeah. Thing is, yeah. And thing, even if you have like the idea of, I've seen people use the storage systems to automatically replicate this data then to a second storage array on another system. The problem is how they are designed is that they replicate every change. So if for whatever reason the data gets corrupted on the first one, that gets replicated to the second one because for the software, the corruption is just a change. Yeah. So it's a little bit tricky and more people rely on that. So for me, a backup is I'll read the data and I write it somewhere else. And for me, the goal is to write it as far away as I can. If I could and would have the network resources, I would put it on the other side of the planet, regardless where I am. Unfortunately, nobody can afford that, so you have to do it reasonable. So what normally happens is to get a little bit ahead of time is I copy it to the other end of the data center and then from there as quickly as possible to some other location. But you have to make an actual copy. Otherwise, you're just playing with luck. And while it's easy with luck to get 100% success rate, but to guarantee it, it's impossible because at one day it will run out. And let's put it this way, the quality of IT products, while for decades it got better and better, now we are at a point where we have a decline again. So a decade ago, hardware lasted at least 10 years, and now we're back down to 7 years. Yeah, because the thing is, and the failure rates are going up. More and more devices are defect either on delivery or within the burn-in phase or then within the warranty phase. Why? Because manufacturers have to make them cheaper and cheaper. And they're pushing the limits. Yeah. When I started on a hard drive, you could manually readjust the read head if you had issues and then close it up again and suck the air out again and rerun the hard drive for another 3 years. Yeah. Today, if you look at the hard drive a little bit in a wrong angle, uh, the the data is now so dense that there are some hard drives that overlap the tracks slightly. Yeah. And so whenever they write the track, they also have to write the track next to it kind of. Otherwise, it would lose the data. And then every like 10 tracks or so, they put in like an emergency or a maintenance track where they can stop rewriting everything. It's what they do. It's called shingle recording. It's started with hard drives around 24 terabytes, and now at about 30 terabytes, they stopped doing it again because it's horrible. Also the drives. Yeah. Uh, Shingle magnetic recording, MSMR or something drives.
Yeah, that's the
Uh,
first I've heard of that. I know what I'm
yeah,
using to make.
you would have noticed if you put it in a disk array because the disk array, when you write, loses like 50% performance because it has to rewrite everything all the time. You could not use that for backups, hilariously, because they write so much that they never keep up with the demand. So it works for regular applications, but it doesn't work for backups. Anyway, so I'm digressing. Yeah. So backup restore has one big advantage. You can not just use it for backup and restore. You can also use it to refresh lower environments like testing, development, and something like that. Just be sure that after you restore there, you make sure that data that developers and testers should not see is no longer in the database before you hand it over. You can use it to create offloading databases, like a copy of the database where you can do some very complex analytics that doesn't need the latest data or something. I mean, you can do this today with readable secondaries or something on the live data. but often from a licensing perspective, it's cheaper to not use that technology. Yes. And of course, you have or can use it for seeding things like high availability copies for mirroring and always on. And you can use it to archive. I've seen many companies that like create a new database every year, and then after 7 years or so, they take a final backup, store it somewhere, and get rid of the actual database. Yeah? So backups can be used for a lot of things, and that's an important thing to know because you have to, you need to do them anyway. You need them anyway. So if you can sell them for multiple purposes, you can charge your customers or your coworkers for multiple things and kind of increase your recovery budget by selling the feature that you can nicely give them copies in development and all these areas. Yeah, so that's why I'm mentioning that thing is, yeah. Uh, what does a backup restore protect you from? Unwanted data deletions. So the famous delete without a where clause or the accidental drop table or something else. In your backup, you still have the data. You can bring it back side by side, copy just the data over, or roll back the whole database to the point in time when the incident happened, depending on what you need. Yeah. Same goes for unwanted data modifications. So if you do again the update without the where clause, a backup can save you there. Data corruption, if your underlying storage has a problem or solar flare goes through your data center, whatever, that will help you there. Of course, it will save you if your storage system fails and the data is gone. It will help you if your whole data center explodes and you have a copy of the data somewhere else, and we'll get to that. Um, and it will help you with physical theft. If someone goes into your data center and steals your equipment and you have a backup, at least you can still run. And that's a question for a different story. What is more important, that people cannot steal it or that you don't lose the data? So what's harder when it gets stolen, that neither one of you has it in the end, or that you still have a copy, but it might enable whoever steals it to also have a copy. And of course, it can help you with ransomware, as we talked in the last session. That's how we got here, um, to protect you from that. To plan what you do is you have to start at the right end and you have to plan your restore requirements and not your backup requirements. You have to know what, in case of a failure, what do you need to be able to restore? Because if you start with your backup planning, then the restore is pretty much set in stone. You have to figure out what you need and then figure out what you need to do to get there. Yeah. You can't start at the backup end. Most people plan backup. Yeah, let's do full backup and diff backup and log backup and whatever. And this is the frequency. And then like, okay, and why? What's the requirement? And will that actually get you to that point? Yeah. So I usually start at the end, the restore. Yeah. And even for the restore, I define something what I call the impact level, which is basically how much can go wrong at the same time. Because we all agree restoring a single database that failed is much easier than restoring all databases in a data center. Uh, Depending on the size of your company, that might be a couple of thousand. So just issuing 1,000 restores, if you have to kick them off, if you fully automated the restore, but you still have to kick them off one by one, if you have to do this 1,000 times, that will take you more than a day. So you have to figure out what it is. So I usually declare the impact levels as normal operation. We have a planned restore for something like seeding a database, or it was planned, there was a planned patching of something and it went wrong, but everything is actually working. We just need to roll back to some previous point in time, but we are fully operational and nothing is impeding us. Yeah. The second one is an instance failure. So we have a broken instance and we have to recover that to a standby instance where we can restore, or if you don't have standby hardware, it doesn't matter how fast you restore. Getting the new hardware will take longer. There's no way you can get hardware so fast that it doesn't matter. I mean, even if Amazon has next day delivery, we're talking 2 days till you get it, today and tomorrow. And even if your favorite hardware vendor puts it in the truck of his car and drives it over, we're still talking multiple hours, and then someone has to put it in the cabinet and cable it, and we're talking. If you have to order it from a big vendor and then they have 3 week delivery, it doesn't matter how long your restore takes. Yeah, it's so often the planning of the backup is much more, do I have somewhere to put the backup is the bigger question. Same goes for like side-by-side restores when I need to restore a table. I have a rule that on every server, I have to have the space of the largest database free, so that doesn't matter which database I need to restore side by side, I have enough free space to do so. So my warning is not at 10% or 100 gig or something. My warning is I'm within a gigabyte of the largest database, which can be changed during the day. So in the morning you're fine, in the afternoon you're not fine, and because the database grew or something. Yeah. Okay. Uh, Another funny one is if your DR side actually fails, and you have to refresh that one, which usually is much harder than your primary, because your backups are usually where your primary runs, which is the last place they should be, but that's what normally is done. And then, of course, we're getting into the area of multi-instance failures. That means something bigger happened in the data center, water came in, a tornado sucked all the equipment out, or something like this. Again, usually when you have multi-instance failure, unless you can get running on a DR side, which might be that you have standby hardware there, but it's not actively running. That's a valid way of doing things. Not everybody wants to spend the power. And it really depends on your business. There's lots of business out there that is perfectly fine with like a 24 to 48 hour outage that doesn't run the business. If you're Amazon and you're selling 3,000 packages per second or something, that's a different story. Yeah. If you're not running for 2 days, everybody's switching to a different shopping site. Yeah. But a lot of businesses, it's this, we need to be available 24/7 is a dream, but not a requirement. Yeah. And even I worked in a 24/7 online gambling thing. We had hours every day defined. If we have an outage, it's not critical, because an outage was only a problem. It was a site where you could bet on soccer games. And it was basically like, we should not have an outage like an hour before the game starts and till like an hour after the game ends. The rest of the day, if we had an outage for 1 hour, we just noticed that in the next hour we had twice the business as we had normally, because people were just pressing F5 till everything run again. Yeah. So it's often not. Or I worked for a hedge fund, and their requirement for the trading system was it has to run for about 10 minutes every day. Everything else, we don't care, because we do all our trades within this 10-minute window at the end of the trading day. So if the system is down the rest of the day, we don't care. Please maintain it every day so that it's in tip-top shape for this 10 minutes. Yeah. We were actually thinking about like 3 hours before this thing happens or so to reboot the machine every day to have it like in the best possible shape. Yeah. So the impact levels, the reason I have these impact levels is it's very clear to every person that has any kind of logical thinking that the more is broken, the longer it will take. And you need to define how long do I need to be able to keep up? Yeah. I mean, what's realistic is that someone says, hey, if a database fails, we want it back within 8 hours. Yeah. So basically, beginning of the next business day, everything should be fine again. Yeah. It fails somewhere during the day. You have basically the whole rest of the day to fix it. Tomorrow we need it again. Yeah. There are systems where it's like, no, you have to get it running in 4 hours or in 3 hours or 2 hours or 1 hour. Yeah. And we will learn it is possible to do that. Even if you have to copy the backups through network these days, restoring, you will see very soon how fast you can actually restore. It's not a thing. So once we know the impact level, so I do different SLAs for each and every impact level. So in the normal operations, I would easily guarantee something like I can restore databases up to this size in like 3 hours, and everything in this size to this size in like 6 hours, and then everything up to our largest database, I guarantee you 8 hours. Yeah. Except for the one database for the data warehouse that is 10 times larger than everything else, that will take 24 hours or something like this. Yeah? So I would have different SLAs based on size and impact level. Yeah. And if I have to go, I have to restore every database on the DR side because our failover plan to DR didn't work and every database got corrupted in the process. Then I guarantee you it's 48 hours and everything is back up. Yeah. So different levels things. If you don't do that, you are just making your own life miserable when it actually happens. Yeah. And I always make the joke when I talk about SLAs, it's like a prenup. You put it in writing when you're still in love, yeah, which is much easier to negotiate. If you have a good understanding with your manager, you can negotiate an SLA with him, and he will sign off on it, and he will then go to his manager, and they sign off till everybody in the company agrees to it. Yeah, if the company website is currently down and everybody's yelling at everybody, you cannot negotiate anything. You can pull out the paper and says, you signed that I have 4 hours. Come back in 3 hours and 15 minutes and we talk again. Yeah. And you keep working and you probably will succeed. Yeah. But nowadays. Good. The next thing you have to define is the recovery time. So we are actually talked about this already. The recovery time objective is how long can it take? And um, here is thing is what I usually like to put in is I like to define two things. Either this is how long the largest database is going to take, and everybody else is going to be faster. So you have one big database, this is going to take 8 hours, and every other database is going to be faster than 8 hours. Yeah? I'm not telling you how much, but it's going to be faster. Yeah? So all I have to worry about is get all the hardware and everything right for the large database. If this is within my N hours, 8 hours, 4 hours, whatever is necessary, then I'm fine. Or the other version is that I define restores take 1 minute per terabyte or 1 hour per terabyte, depending on the infrastructure. Yeah. So let me make you a little bit funny. Uh, on modern hardware, you should easily be able to restore a terabyte in 7 seconds through the network from a file on a file share to your database server. Yeah. Terabyte in 7 seconds. Will you be able to do this on what you have in your data center? Most likely not, because marketing prevents you from doing that. You have so much equipment in there that slows everything down so much that is not possible. Yeah. But you can do that, and I will show during this session how to build very affordable hardware that can actually do that. Yeah? To put a little bit math around that, to restore 1 petabyte, it will take 2 hours. Yeah. And that is again not unreasonable anymore. Yeah? And that is not high-end hardware. I can go faster. This is just with hardware that can be bought reasonable because hardware cost is always this like it's like 10 gigabit, 25 gigabit, 100 gigabit, 400 gigabit. Yeah, there's always the point. It scales in a reasonable way and then it goes up. It's like hard drive sizes. Yeah, 24 terabytes, 26 terabytes, 28 terabytes, 30 terabytes, 32 terabytes. Yeah. Right now, I would not buy a 32 terabyte hard drive because it's so much big. The cost is so much higher than a 30 terabyte, and you're not gaining that much. Yeah. So you're paying twice as much money, but you're getting only like 10% more, not even 10% more capacity over the old model. Yeah.
Yeah,
That
I've
I think.
I've been looking at a 400 gig switch for my house, and yeah, it's not the best price.
No, I mean in the winter it's great because it saves
Oh
you a
yeah,
lot even heating, but
oh yeah,
and you could put that in, but you pay it back in the summer on cooling. So
yeah. Power in Nebraska's cheap, so
no, but it's yeah, no, but for a company in the data center, a 400 gig switch is not out of the possibilities. 64 64 ports, 400 gig should be 25,000 without the plugins, just
yeah,
the switch itself. Yeah, because honestly, all the network switches these days in the high end are using the exact same chip. It's the one chip, and the chip exists in a 100 gigabit version and a 400 gigabit version and an 800 gigabit version. The 800 bit, insanely expensive. The 400, expensive, but not insanely. The 100, got cheap right now. If you have a 25 gig switch, it's the 100 chip. It just slices every port into four. Yeah. But it's the same chip as the 100. And the 10 gig switch is the same thing. It just slices every port into 10. Or it slices the ports into 25 and then uses them only at 10. Yeah. It's in the back, it's the same freaking silicon piece. Yeah. Because it makes no sense to develop different ones. 30 years ago, there was a big difference. Yeah, but now I remember it was when I was still at the gambling company, it was cheaper to use 64 1 gig cards than four 10 gig cards. Yeah, because 10 gig cards were so insanely expensive at the time. Today, a 10 gig card costs what, $200?
if that,
Uh,
yeah,
yeah, a good one. Yeah, that
yeah,
offloads everything. Yeah,
yeah,
the one that the CPU does everything you can get for like it's free on the motherboard. Yeah. So yeah, but if you build it wrong, the same petabyte can take 11 days to restore if you don't plan ahead. Yeah. So I've seen people do the math for like a single database, but then they forget, oh, what if I have to do like three of them at the same time? So it's you have to, and that's why I said you have to define what are the impact levels and up to which impact level do I guarantee a certain time. And you cannot define, can I do a terabyte in 7 seconds? Yes. Can I do 2 terabytes in 7 seconds in the same hardware? No, because that pushes whatever I have to the limit. Yeah. Could I build hardware that can do terabytes per second? Yes. But that becomes, in my definition right now, insanely expensive. The limit right now is about a terabyte every second, 7 seconds. And by the way, that's not the limit of the backup filer. That's the limit of the database server, how fast you can write to it. Um, One very big thing that everybody forgets when guaranteeing these times is you have to put blame onto the developers as well. Because after you restore, you move the data physically back to your database server, there is a process called rollback that the database will do. And that might take a while. If your failure happened like during a 6 day index rebuild, it might take another 6 days to roll that back before you can use your database. So you have to have in your SLA that after you restored it and rollbacks happened, that's a developer's problem, not yours, because they wrote code that takes that long. Yes, in SQL 2019, there's something like advanced database recovery, which is great. except that it has some side effects, like you're not using TempDB anymore because all TempDB transactions are now happening in your own database. You still reference it like TempDB, so you don't have to change your code, but it goes into your transaction log, not the one from TempDB. And you're suddenly introducing snapshot isolation to your data, which adds about 10 bytes per row on your data. And if you have billions and trillions of rows, that might break the bank on how much space you suddenly need. So careful there, because especially with column stores, I've worked on a column store that stored 168 bytes of data in each row, which was not that much. It was a bunch of eight byte values, but the compression ratio was 32 to 1. So we used 4.5 bytes per row to actually store it. And when you add row versioning to it, you add 10 bytes to that row. So instead of 4.5 bytes, you now use 14 bytes, which is basically 3 times as much, 3 to 4 times as much. And so advanced database recovery is great if you can afford the extra space and you slowing the system down a little bit during normal operations. But on the other hand, I've never seen any recovery take more than 10, 15 seconds, regardless of how long the transaction was technically running before, because it's really good at what it's supposed to do. I cannot explain you how it works. I bought the book. I read it like 10 times. I still don't understand it. Um, I tap out after like 50 pages of like a 110-page book. At page 50, 60, they're doing things my brain just doesn't understand. I said it before, you need exceptions for your recovery time objective for like things like data warehouses and other things, but you might also have exceptions into the other direction, like your most critical online OLTP database for your web store. While you guarantee 4 hours for everything else, that one you might guarantee 2 hours, and you might have to do something special to do that. The next one is the recovery point objective, is like, how much data can I lose? And to be very clear in the beginning, no DBA ever in their life went to work to says, today I want to lose 7% of the data. No. Everybody goes to work and like, I don't want to lose any data. That's the normal thing you do. The problem is at some point you will lose data. Technically, you can build solutions where you don't lose data, but I've only seen one company ever do that. Because the only way you can guarantee zero data loss is that the moment you cannot guarantee zero data loss anymore because something failed, you have to turn off the system. And I've never seen a company that was willing to give away availability for data loss or prevention of data loss. That you're like, okay. And the other one is you need at least 3 sync replicas to do that, because with 2, it's impossible. You need 3 sync replicas to do that. And thing is, yeah, it's possible since SQL 2017. They added a feature where you actually can tell an availability group to have zero data loss. Almost nobody knows that. And we can do one day and like have a demo on that. It's hilarious when you like corrupted the DR side. You corrupt the database there and your primary just shuts down, says, okay, I can't take any transactions anymore. Because what people don't understand is in a regular AG, if the DR side fails, the primary side takes a 10-second break and then continues and doesn't care about the DR side anymore and doesn't send any data there. And if you then fail on the primary a little bit later, all the data between the first and the second failure is gone. And yeah, that's what it is. Yeah. But back to the recovery point objective. Yeah. So it ranges from everything to zero data loss. And I'm not joking. In every company I worked, I found multiple databases where if the data gets lost, we don't care. Yeah. Prime example is you have a database called session state server. You are synchronizing your web servers through a database with each other. Yep. If that database is gone, you don't need a backup. you put a new empty database there, and the web servers just continue as if nothing happened. The users might have to relog in, but that's everything it is. If you restore that database, it's probably going to be a worse state because users might suddenly be in a different place than they were currently. If the system just recovers from zero, and so all you need is an empty database somewhere ready to go, and you're fine. There's even an implementation for the session state database where you can put it in tempdb and it runs faster. So you can run your session state in tempdb. Another example is a database called IP2Location that I found pretty much in every large enterprise. It's a company that sends you every month a new database backup with the data. You don't need to take backups. You have the backup already. It's there, and next month you get a new one. It's basically a database that has one table in it. This IP address has this address. And you can buy it in various granularities. It comes from a couple of megabytes to several hundred gigabytes in size, and depending on the money. It's very helpful to figure out where people live when you have the IP addresses. And it's amazing how much data your ISP is selling to this company. This and another one is when you buy stock ticket data from Bloomberg. There's no point in taking a backup. Within 2 hours, Bloomberg, if you live in the tri-state area, within 2 hours, Bloomberg sends you a new device. You have a problem, the new device arrives way before you could ever restore that thing. Yeah. They have a battery of machines that they keep current, and if you need one, they take it out, put it in some bike messages back, and they cycle to you. Um, Other ones is days, hours, minutes, seconds. You have to define what for your database is reasonable. Yeah. If you have a place where people take paper orders that come in per mail and type them into a system, you can lose a whole day. Yes, it's probably a lot of work for the people to type all the stuff in again, but you can recover the data. You don't need to build some crazy thing. Or I once worked on a database in a call center where whenever they took a call, they needed to write down how long the phone call was so they could charge the customer they worked for. And the way we handled this there was we took one backup per day, but what every client kept was a log of all the T-SQL statements they sent to the database. And each statement was written in a way that it would figure out if it already ran. So if you had a problem, all you took that file and it was conveniently called .SQL at the end. You opened it up and you pressed F5 and it recovered all the data from each and every workstation. So worst case scenario, you had that. So what I'm saying is, if you are constrained with budget, don't lower your overall SLA. Just find the outliers where you can resolve the problem in a different way. Yeah. Don't compromise everybody because people are wasting it. Yeah. Another database I don't care about is called Lunch Menu in many companies. Some application to have that, or no, there's databases. Who cares? Yeah. I mean, Lunch Menu databases are usually small, so they don't count, but it's it's something that happens. Yeah.
Well, it depends
So
on who you talk to. Lunch menus can be vitally important for some people.
yeah, but yes, but the company will still be there tomorrow if the lunch menu is gone. Yeah, if the the credit card transactions of the last 2 days are gone, I'm not so sure if the company is still there. Yeah?
Slightly more
So
important.
for the recovery point objective, what I like to do is have like a bunch of sentences that are very simple but define very clear things. Yeah. So first sentence would be 100% of all databases must be able to recover to some point in time within the last 2 weeks. So let's assume I take daily backups of my data. That means in the last 2 weeks, I have 13 to 14 backups. If I, as a DBA, cannot manage to get one of them working, something is real wrong. I mean, you still have the monitor, but within 2 weeks, I can figure out something's broken in a backup and I can fix it. So for all databases within 2 weeks, I will find one backup that works. Yeah. You might lose 13.9 days of of data, but I guarantee 100%. 99% of all databases must be able to recover within the last backup cycle. Yeah. Backup cycle, in my opinion, is always 24 hours, except in some companies I defined the weekend, Saturday, Sunday as one cycle because there was no point in taking a backup on Saturday and the same backup on Sunday because nobody was working on Saturday. This is especially in like office business types of buildings. Make sure you're not taking the same backup Saturday and Sunday. There's no point if nobody works on Saturday. There's no point doing it twice. Yeah. So within a cycle, that means 1 out of 100 databases can fail. Yeah. That means every day, let's say you have 300 databases. If less than three fail normally, you are good. Yeah. And even if a backup fails, you will still have probably the log backups and you can use yesterday's data. You just have to make sure that for 1 out of 100 databases, you have not multiple consecutive failures of the databases, which is doable. Because usually what you should do is every day you should check, hey, have I any failed backups? And then this should be blinking red at you if you have 2 consecutive days of the same database failing. One day, not a big deal. 2 days in a row, you probably should have to manually interfere with whatever you built. Yeah. And then 98% of all databases to any point in time within the last 2 weeks. That means that I can do actual point in time restores to the databases that need it. With two of them can fail, and then with three of them failed, any point in time between the last 2 and 8 weeks. And that is a question again. There was the definition that we need up to 8 weeks of point in time recovery. Yeah. Most places I worked for, they want like 1 or 2 weeks uh, point in time recovery. I've seen some companies that want 32 days, so they can always go back to the beginning of the month if they have to. And again, it depends. The important part is you have to negotiate it and write it down while everything's working. Because again, you cannot negotiate any of that when it's already broken. Yeah, it's when it's broken and you start negotiating, you will probably use your job and your manager might too. Yeah. Um, thing is, the next big part is what makes negotiations the hardest because nobody knows the answer to the question. Is how long do you need to keep the backups? It's the retention time. Yes, for you, for the recovery, you need it for like a week, 2 weeks, a month, something like this. And in that period of time, you want as many copies as possible because that's the backups that you need to guarantee the business keeps running. But then there's a second part is almost every industry these days is regulated in some form and has requirements how long they need to keep backups. These laws were written by people that had no clue what they were doing. The problem is you have to be able to comply with the law. Yeah. Again, if someone needs a 6-year-old backup from you, that's not to keep your business running. This is because some lawyer requested it to prove something. Yeah. It's part of discovery in some lawsuit or something. Yeah. So these long-term backups, yeah, or the retention backups, or like I like to call them the legal backups, the one for the legal system. This is the hard part. How many, how granular, and how long do you have to keep them? And I can't give you an answer because every business is different. I worked for businesses that had zero requirements. They could, after our recovery period of 2 months was over, they're like, yeah, delete it. We don't care. We don't need to keep any backups. Yeah? They couldn't find any law that required them, any rule, any regulation, so they were not keeping any backups. Like, okay. Worst case scenario, we pay some fine. Cheaper than keeping the backups. Second, I worked in a regular financial company 7 years. That's if you have no idea, 7 years is a good idea. Yeah, because the majority of rules and regulations is somewhere in the 7 year range. Yeah. But I also worked for a company that produced a product that was related to human plasma. And the 7 years immediately became 30 years because they have to keep all data for 30 years because if human life is on the line, that immediately jumps to 30 years. And I've worked for a company that had certain data, which luckily was not in a database. So it wasn't my problem, was someone else's problem, but they have to keep it forever, which means basically till the form of government we have today doesn't exist anymore. But for now, you cannot delete that data. It's a couple of gigabytes, but still can't go anywhere. So that was a funny part. Yeah. So you see, it can be anywhere. And this is the hard part. Nobody knows the answer because the people that know the answer are lawyers. And unless you have general counsel in your company, you will not get an answer from anybody else that is 100% correct. And the harder part is even with all the laws and regulations, if you only work and do business in one country, it's easy because you find a lawyer, you pay them some money, and they tell you in your industry it's that many years and you're fine. Yeah. Problem is once you start offering your services or your business in other countries, now you have to look at their laws and regulations as well. And I once worked in an industry that had different regulations in each and every country. So I came across a funny problem that in 1 year, in one company, I was required to keep the data for 10 years, at least 10 years. And in another country, I was not allowed to keep the data for more than 7 years. So I wrote a very intelligent question to to the owner of the company, which I attached two pictures of the jails in the two countries and asked him which one he preferred in case we ever have an issue because I can either delete it after 7 years, then you go to jail in the country that requires you to keep it for 10 years, or I keep it for 10 years, then you go to jail in the country that asks you to delete it after 7 years. Take your pick. We found a solution. It was about 6 months work for the development team. They had to rewrite the whole application that it had now a different database for each country. And this one we kept 7 years and the other one we kept 10 years. Yeah. Man, that solved a lot of other problems, but it 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 is hard. Yeah. Or I mean, the majority of the audience in this is probably going to be from the United States. So the thing that's called GDPR, which is the laws and of data protection in the European Union, yeah, there are stupid things there that people can literally send you a letter that says delete all my data. That means you also have to delete it in all the backups. Which luckily they changed the law that you don't have to do that anymore because before that you literally had to restore every data backup, delete their data, and then take a new backup and keep it for the remainder of the time. So now you can have a process. Once you restore a database, you have to run a process that scrubs all the people that ask you to delete their old data.
Sure, but then
Uh,
that created an issue where the original backup was no longer maintained for 7 years. So that's why the law had to be changed because it put them into a
yeah.
into a
The
quagmire.
fun part is to have the list of what you need to delete, you're actually breaking the law by keeping a list of the name of the person that you need to delete. But okay, they will figure that out in the third iteration. My tip is make sure corporate counsel or someone hired was consulted and signed off on whatever the retention policy is, because I guarantee you neither you, nor manager, or his manager, or even the owner of the company knows the correct answer. Yeah. You can do a good guess, but you need someone who knows the laws and regulations of your industry can sign off, and lawyers have insurances to cover that. If they give the wrong advice, their insurance will pay all the fines and not you. And these fines can be really hefty in some industries. Also, when you do this, what is very common that people take like end of month backups. Yeah. Okay. When is the end of the month? Again, if you work in a single country, it might not be a big issue, especially if the country is small. In the US, it's already different because if your headquarters is on the East Coast and you have a store in Hawaii, your end of month and the end of month in Hawaii might not be on the same day, depending when you do that. If you add business in Europe and then Asia to them, you're suddenly, um, the fun part is humanity was so stupid in creating time zones that time zones actually span 2.5 days. And yes, there's somewhere in the Pacific where there's two islands that are north-south from each other, and they differ by 2.5 days. So if you want to get really much younger, you just swim from one island to the other, and you got two days, uh, 2 days back. Uh, the other funny thing is, it's amazing how many lawyers are on these two islands because they get used all the time to file things that were late because they can still do it because it's the day before yesterday. Hilarious. So you have to define when the end of the month is. My definition that I use is I say I either take it on the third day. I keep the backup from the third day after the end of the month, or so the third day of the next month, the full backup that I take there. And if I don't take full backups every day, then the first full backup after the third day. Because with the third days, I cover the 2.5 days that some stupid time zone shifting can cause. And then the next one after. Usually to having too much data in there doesn't matter as long as you have the end of the month. People that use the backup from the 31st of the month or the 30th or the 28th or 29th, first of all, this is complicated. Yeah. The end of the month is a very varying thing, and you have to track it in complex ways that change every 100 and 400 years and stuff like this. Because even not daylight savings, what's it called, the extra day in February, um,
Leap year.
leap years. Leap years are not very constant and the same. They're not every 4 years. There are exceptions when they are not. And the exceptions just get more complicated the longer the planet keeps spinning. Um, so that usually the 3 days covered it, but it might be that you just have to define what the end of the month is. Yeah? In the online gambling company, we defined it 5 minutes after midnight, 2 hours, 2 hours and 5 minutes after midnight UTC. That meant we had like 99% of all soccer games played in the database at the end of the period or the end of the day, because we couldn't get 100 because the first ones were already starting the games of the next day before the last ones on the day before were not finished. If you look at the whole planet through the 2.5 days, because apparently soccer is played on islands as well, even in the Pacific. Uh, so we had to define what the end of a period is. And it's the end of the month, it's the end of the day. It's the same thing because you probably want to take your full backup after end of day and not in the middle of the day with every full backup to cover the full day before. Okay? Uh, and next big question is you're doing the backups before or after maintenance. So you have some daily maintenance, things that you have to clean up every day. And this is so you have end of your business day, maybe. Your business might be 24/7, then again, you have to define some point in time. But if you have like typical 8 hour, 10, 15 hour business days that cover like Europe and the US with like 20 hours, so you have some end of business day. You might want to do the end of day processing, which usually is like 1, 2 hours. I've rarely seen companies that take longer, but it's possible. Um, But then are you doing maintenance before or not? The problem is, I explain you why this is a big decision. So let's start. We do the backup before the maintenance. Great. We finish the day. Business processing is done. We take a backup. and then we do all the maintenance. That means we now create an insanely large log file that in every restore we have to apply. Because if we want to go to any point in time on the next day, we need that full backup that doesn't have the maintenance in it, and then have to replay the log restore from the maintenance, which might be some heavy index rebuilds if you have to do them on a little basis. Yeah? So again, either you keep your maintenance very, very small, just a couple of update stats or something, then it doesn't matter. But if you have some index rebuilds in it, doing the backup before the maintenance might slow you down on a restore on the next day. Problem is, if you do the backup after the maintenance is, what if the maintenance runs late and then you're running your backup into the business day? Yeah. Yep. So thing is, you have to find a compromise. If you have your maintenance really good organized, you can say, okay, I run maintenance for 3 hours, and wherever we are at the end of 3 hours, we stop it there. That's a possibility, but not every maintenance script is capable of doing that. So might be a problem. So good. So now we have an idea what we need to define what we need. So we now know where's our requirements. How long do we need to keep backups? And how quickly do we want to restore them? And to which point in time do we want to restore? There's hundreds of other things you can define, but these are the three basics. If you don't have these three down, the rest doesn't matter. But once you have these three, you will stumble across the rest and you will find a way to deal with the rest. So we have these three. So now we have to figure out how to restore. Before we get there, I want to tack on one more like sidetrack, but then we have it out of the way. The long-term storage. This is always the problem. Where do you store your long-term retention backups? Because short-term is very quick. It's very easy. You have them on some hard drive. Yeah. SSDs are still a little bit expensive to keep like 2 months of backups, but they're getting there. Give it another 5 or 6 years, and spinning hard drives are probably gone. SSDs, by the way, are already larger than spinning drives. So if it's about density, SSDs already win. If it's about power consumptions, SSDs already win. If it's about durability, SSDs lose. And we're not talking about wear leveling that when you write too many times. One thing that many people don't know is if you write on an SSD, $300 multi-terabyte SSD, and then you put it in your safe and you pull it out in 2 years, this thing is empty or at least corrupt. If SSDs are not powered, over time they lose the data because they're not actually burning the data in. They're just flipping atoms. And after a while, they flip back. So SSDs, if you keep them powered, they'll never lose the data. They are way better than hard drives. Hard drives, if they spin, they lose the hard drive. Hard drives usually, I think it's 60. If a hard drive would not have a mechanical failure, it's 67 years when it's going to be empty. Just the magnetic field degradation over time. Because the Earth spins through a magnetic field, and that goes through each and every hard drive. Even they are nicely shielded and everything. No shield is perfect. So after thing is, I think every couple of months they lose like 1% of the magnetic charge they have where they have the thing stored. So after a while, they are guaranteed to lose the data. The fun part is that tapes are actually the most reliable thing to have the data as long as you move them every couple of years. So if you put data on a tape and then leave it, again, the layers of the tapes are pressed closely to each other. That doesn't last forever. But if like once a year you just spool it from one end to the other, you don't even have to read it. You just have to like for the older people under us that still remember like rewinding it, VCRs, all you have to do is wind it all the way to the beginning, wind it all the way to the end, and you're fine. Yeah, do this once a year, have some very unpaid intern do this to all like your tapes, and you're fine. Problem is, even with that, tapes have a failure rate of about one read-write error, as a one defect block every in 7 years. 1 out of 5 tapes will have a read-write error, which on normal backups is not a big deal because you can, yeah, some one file is defect. You have a million files on your file server, you back them up, one of them is gone. Problem is with databases, backups, it's one gigantic file. If one block is gone, the backup is unusable. I mean, you can still restore and then you have a corrupt page or something, but um, it's not something you want to deal with in a restore situation. So tapes have a problem that they lose thing is, and I did a lot of math on that stuff. Yeah. Today tapes that I use are between 2.5 terabytes and 18 terabytes per tape. This is raw capacity. They all claim they can compress. They can't. If you have a compressed backup from SQL, they compress nothing. They make it bigger even if you compress. Yeah. And it's an 18 terabyte tape is about 92 euros. That's what you can buy them on Amazon. I'm not getting about, you can, if you buy them in bulk from a vendor, you probably get them much cheaper, but I use list prices on websites to make this comparison. Yeah. They are fast enough. It sounds funny. They can only do like 400 megabytes per second, but still you have a whole month to fill them with a 1 month, one backup per month. So take this times 30 and you're fast enough to store all that. The problem is with the failure rate of one one of each 5 tapes is broken. That means if you need uh one tape per database backup. If your database backup fits on one tape, you have an 80% success rate. That means 20% failure rate. If you need 6 tapes, you are down to 26% success rate after 7 years to restore that data, which is probably not good enough. And to compensate that, you need to have multiple copies. So if you have like 3 or 6, if you have 6 copies, you're back to about 80% success rate for 6 tapes and 99.99% success rate for one tape per backup. Yeah. But you need 6 copies. And you need to store them in 6 different places and keep a lot of work doing. Yeah. So I did the math, and it's really interesting. Um, and let me share this. This is easier than talking thing. No screen. I have too many screens. This one.
Nah, you just need a bigger neck.
It showed me 6 screens. So you should now see a little table. Let's see if I can
Yep,
make it.
now we can.
Yeah. So this is the 6. If I keep 6 backups and I store them in Iron Mountain, it costs me about $1 million. For 7 years, 20 petabytes. Yeah, and that's not that much. 20 petabytes for 7 years per year. That's a little bit. It's like 2.5 petabytes. That's per month about 200 terabytes. That's not unusual for a backup sizes in a company these days. If I put them in like my neighborhood storage facility, that cost goes down to about 500,000. And if I put it in the basement of my office, I can save about another 50 grand. That's it. Yeah. If I do a mix of the 3 storage things, I get about 700,000 per year. So I put 2 tapes in Iron Mountain, 2 tapes in a storage facility, and 2 tapes in a secure room. Yeah. If I put the same thing in AWS Deep Archive, and again, list price only, not negotiated prices, you can get that way down. I get it to about the same price as they are in Mountain and zero hassle. It just sits in S3. If I need it, I pull it back. It takes 12 hours to get it back, but thing is, um, the only problem with AWS Glacier Deep Archive is if I ever need it out of there for whatever reason, all of it, it costs a fortune. It costs about twice as much to get it out than it costs to keep it there for 7 years. So if I just want it out because I don't want to pay AWS anymore, it's cheaper to pay them the rest of the contract. Just don't put anything new there. But if you need to get it out for some legal reason or whatever, it costs a fortune to get data out of the cloud. And that's not just AWS. Every cloud provider is this. Getting the shit in is cheap. Getting it out costs a lot of money. And this takes into account all network transfers and monthly connection fees and everything you can think of. Yeah, it took me several days to compile this data. Yeah. If you're interested, at some point I will release all that. It's like pages and pages of doing the calculations and all that to compare this. But what I want to say is, if you don't have any plans of getting it out of there, uh, this is the only thing I've ever found where the cloud is actually cheaper than doing it the right way on-prem. Everything else, it's not cheaper. AWS Deep Archive Glacier is really cheap. It's like $1 per terabyte per month. This is where it kicks in. Yeah. And this includes the cost of in your data center, the rent for a port at a third-party provider that provides you direct connect to AWS, the region transfers, copying from one region to the second region, because if you have 6, AWS Glacier gives you 3 copies in the same region of the data. But with 6, I said, okay, I want it in a different region. Yeah. So this includes the cost of getting it from like the East Coast to the West Coast, or even to Europe and the US if you want to store it on 2 different continents. It's the same price, by the way. It costs the same moving it from New York to LA as from New York to the UK or somewhere in Europe. Technically, UK is in Europe, but I mean the European Union thing. So stop the sharing thing. So this in mind, when you plan your long-term storage, you might entertain the cloud as a valid option. Yeah. They even recently introduced a new thing where you can isolate it from your account, meaning that even if your account gets hacked, you put it there and then transfer it into the isolated vault, where if you get hacked or your normal account with the cloud gets hacked, they can't access that data. Problem with that is that costs more. It's like a couple of lines of code somewhere and they just charge. And with more, I mean more than double. Uh, yeah. The nice thing is AWS guarantees you. So I did the math. Um, you need more than 1 billion backups to have the chance of having a broken one. That went down a lot because what they guarantee you is like 11 nines of durability on what you put in S3. So 11 nines, that's a lot of zeros when it comes to how many S3 objects you have to put there to lose one. The difference is when I started this, an S3 object was limited to like 14 megabytes or something in size, which made it not very attractive for backup files, but you could still take your file and split it into thousands of objects and do them. And they supported that feature actually. So now the new limit for object size is now 50 terabytes. So unless your backup file is more than 50 terabytes, which I've never seen one in that size, even with trying to get it to that size. And you can split the backup into 64 files. So easily uploadable there. So there's a good chance. And with that, and the same 11 nines on durability, now every backup file counts as one. When you had the thing that you needed like 10,000 objects to store a single file, the 11 nines quickly became a risk factor. Now, since this is like every 50 terabytes is like one file, yeah, it's not happening. That I could not get it to anything close. So I did the math for 20,000 databases with log backups every minute, and everything split into 64 files and stuff like this. I still couldn't get it to a number greater than one for number of files lost in 7 years. Yeah, so it's safe up there. So thing is, I don't know if they really guarantee it. I don't know what happens when you only have it in one region and the whole region is underwater. If I haven't found the fine print yet that told me I have 11 nines, but we actually only mean like two. Uh, it's usually these fine print is somewhere. With S3, I haven't found it. And S3 is such a fundamental feature in AWS that I actually believe that it might be high quality. So, so long-term backups, my recommendation now is put it up in the cloud. And by the way, also the performance issues that I had when I started investigating this in the 2019 or so, the limit was how much we could push up there because back then you could only get like gigabit Ethernet connections to AWS. Now you can get 400 gigabit per second connections. And they're not much more expensive than like a 10 gig connection. I mean, yeah, the switch port on your side costs much more, but they know that you push so much data into their cloud that you pay for that uplink in like nothing. Yeah. Yeah, durability. Another thing with durability of backups is it's not just about the medium, it's also can I still restore the backup? Did the software like SQL Server changes? There's a new version about every 2 to 3 years. And SQL already had a version where they broke the restore ability. So if you had a backup on SQL 6.5 and you wanted to restore it to 7.0, it didn't work. Because between 6.5 and 7.0, the complete layout and size of a data page changed. In 6.5, a data page was 2 kilobytes, and now it's 8 kilobytes, and the content on the page was completely different. So there was no way of doing it. To move data from 6.5 to 7.0, you have to restore it on 6.5, BCP it out, and BCP it back into 7.0. And that's the reason why you can still download 6.5 on Microsoft's homepage. If you go to MSDN and look at the downloads, 6.5 is there, and the next one is, I think, 2008 or 12 or something. Yeah, it's a big gap. But thing is, the other thing is, you can, without changing a setting in the database, which is done by the restore process, if you restore a database taken on SQL 2008 or later, you can still restore it on 2025. Nothing will change. Except if in the 2008 database, your compatibility level was not 9.0. It was lower than 9.0. Then they will switch it to 9.0. Every database backup taken before 2008 will be set to compatibility level 9.0 when you restore it, which will break pretty much every join that is in a database before SQL 2000. Because before SQL 2000, you wrote joins with the star equal thing to define left joins and equal star right joins, and you had the join condition in the where clause and not in the join statement. Yeah, and you had the database names listed with the table names listed with comma separated a list. So that will break. That was the problem why people had such a hard time migrating to SQL 2000 because that was a breaking change in 2000. And then the reason so many people are stuck on 2008 is because 2008 is the last version that lets you use a compatibility level where you can do the bad queries. That's why so many people are stuck on a 2008 version because they don't want to rewrite their code and fix the joins. And the next one, 2008 R2 or 2012 would not let you use that anymore. Yeah, so that's make sure that the thing is if you use third-party backup software, this might even be funnier because make sure that you have the versions of the product that can still read that. Again, SQL team is pretty good reading old backups. If even if they have to like fix things and might break your queries in a 20-year-old backup, the data is not broken. The data is still there. It will run through the database upgrade process for several hours if you restore a 7.0 database on SQL 2025, but it will end up there. And the good thing is databases on 7.0 and thing is they were tiny. Yeah, they were like megabytes, not gigabytes. And then the ones in 2000 were like gigabytes, not terabytes. Yeah. So keep that in mind. Restoring that could be, thing is, I know I still get paid to check a SQL 2000 database and verify every year that it can still be restored. It's one of the 30 years things where a health thing company needs to make sure the data is readable for 30 years. Unfortunately, very soon it's going to be over. Was a nice income every end of the year. Uh,
Do you have to do that with any SQL 2005 databases here coming up?
no, this is like we're talking no, this is a database that was like 7.0. I think the system was delivered on 7.0 and then upgraded to 2000. This thing is old. Yeah, this was the software was written in C++. .NET didn't exist yet at the time. So, good. Now we have all the requirements. Now we have to do a restore plan. We don't come up is how are we going to actually restore to our requirements? Yeah. So when it's about management, they want to have instant restore with no data loss and at no cost. That's clear. Yeah. Unfortunately, that is impossible. Yeah. Thing is, so what is the fastest way to restore a database? It's very simple. You have it already restored before you start recovering. Um, okay, sounds a little bit crazy, but there's actually a feature that the introduced in SQL 6.0 that allows you to do that. Uh, it's called log shipping, and it's called delayed log shipping. So what you can actually do is you log ship a database with a 2 hour delay to some other server. And when your main database fails, you just stop the log shipping and recover the other database, and you have a restore that is 2 hours old. So hopefully, if you detected your problem within 2 hours, you don't have the issue. You can even like inch forward to the point, and then you have it ready. Yeah. So basically, you have a standby restore already ready before you start restoring. And the fun part is, we will cover this in session part 4. How to do that because this is like a whole hour, not just how to set this thing up. Yeah, it works great. Once it runs, it's awesome, and you need a lot of money because to do it right, you need 5 copies. Uh, but if the requirement is that you have to restore, I don't know, half a petabyte database in 20 minutes, that's the only way you can guarantee it in every case to do it. Yeah. So the second fastest way to restore a full database, a database to a point in time is when you're super lucky, and the point in time you need to restore it to is within the time frame the full backup was taken. Because then you can do a full restore with stop at exactly that point in time, and you will end up with the database by just restoring the full backup. No log restores, nothing required, because every full backup you can restore to any point in time during the time period the full backup was taken. Why is that? Because every full backup contains all the log entries from the time when you take a backup. It's also very important to understand a backup contains all the data till the last milliseconds the backup ran. It's not all the data at the beginning of the backup, it's at the end of the backup. So this, and that's the reason why you want to take backups very quickly, because while you take a backup, you cannot truncate your log. Um, it was even worse till SQL 2005. You could not take a backup of your log file while a full backup was running. So basically, for the whole time you took your full backup, your transactions were in danger. Back then, there was no database mirroring, no nothing. In 2005, they changed that you could take a log backup while the full backup or diff backup is running. Before that, it wasn't possible. Could only have one backup at a time. After that is to restore your full backup and then apply the latest differential and then do your log backups if you have differential backups. That is only true if the differential backups are small. If your differential backup is like half your full backup, change your backup strategy to daily fulls because my experience is that the differential backups take about twice as long to restore as the full backups do because of all the shifting around and doing constant moving and stuff. And it's fine. It works. If you don't have the money for daily full backups, I understand it. It's a good way to work around that. But again, if differential backups get too big, they lose the point of because they are meant to be a shortcut to get to the finish line quicker. Yeah. And it especially if you have something like that, you in your business, you do a lot of beginning of the week processing on Monday, which creates a gigantic data change on Monday, which is then in each and every differential backup till the end of the week. And so if you had a full backup on Tuesday and then just a couple of small log files, you would be much faster at the end. Yeah. Yeah. And then, yeah, if you don't have your last full, you have to go to the one before that, and then it takes longer, and then you have to go to the one before that, and it gets longer. And at some point, you reach a point in the past where you have a full backup, but then have a break in the log chain at some point. So at some point, you will lose the ability to actually restore. So having good backups are crucial to having things. The nice thing is that today's backup, so today's networks and storage and hard drives and SSDs and everything are so good that the majority of your backups will be okay, except for about one every 15 terabytes. Because you will have an undetectable write error occasionally, and that means one of the backups will be corrupt over time, even on the best hard drives. An undetectable write error is if 2 bits in one sector on the hard drive flip, and they flip in the worst possible positions so that the checksum doesn't change. And that means you will not detect that you're reading a bad block. You will get it, and then SQL will start up, and the first time you access the page checksum, well, nothing is. Normally, when you do the restore, SQL already checks the page checksum and will tell you that the backup is not good because the SQL checksum is calculated differently than the one on the hard drive, and it's statistical impossible that you can create a bit flip that would fake both of them because that thing is, yeah. Uh, Again, you can prevent this already if you don't use RAID 5. If you use RAID 6, you have two different checksums, and therefore RAID 6 can figure out the correct data from the two parity disks. Or RAID 1 or RAID 10 can also not figure that out. But there is triple mirror rates now because the industry caught up. It's not something they advertise because they have a problem with that. Because it basically tells you that all the storage we sold you over the last 40 years is not good. But now the new one is good. So they quietly introduced that. If you look at, for example, what Microsoft did with Windows Server, Storage Space Direct. Storage Space Direct uses a triple mirror exactly for that reason. It's it's quietly coming. HP RAID controllers all have a triple mirror option now. Yep. And the triple mirror option has three options. Option one, lowest latency, meaning they issue the read to all three. Whoever answers first wins. Doesn't matter what the data is. They have the highest throughput. Every request goes to a different hard drive, or they have correct data. They read it from all three. They compare two. If they're the same, they give it to you. If they're not the same, they compare both to the third one. Wherever you have two the same, they assume this is the data and they repair the other one. How do I know all that? Yeah, I worked with the guy at HP to implement that because we needed it. And it's in every RAID controller now. And so the data there is way more safe than in any storage array that uses a RAID 5 or a RAID 1 or a RAID 10 and only has two data. The problem is undetectable write errors happen. There's nothing you can do about it. There was something about it, but human greed got rid of it. Um, if you look at very old hard drives, their sector size was not 512 bytes, it was 528 bytes. Enough bytes to have two checksums in there to fix that. So every sector had a double checksum to prevent these things. In the early days, they built stuff high quality because back then hard drives were so unreliable that it happened all the time. Now it happens one in a bazillion writes. The problem is in 15 terabytes, the bazillion writes happened. Good. So, um, yeah. So let me share my screen again because this is much easier to hey. So, um, what is my restore plan? It's very simple. You start a restore and what I do is I find the newest and closest full backup not marked failed. What does this mean? Yeah. Is the newest means is the last full backup that I took. The closest means it's the one either in my data center where I want to do the restore or the network distance closest one. So if I have a 400 gigabit network to a faraway data center, that's much closer than if I have a gigabit to a very close data center. Yeah. So on a network throughput basis, nearest thing. Yeah. So basically, where can I read it the fastest? And thing is, and it not marked as failed means we have either no information if that backup is good, or we already have a successful restore on that backup, but we have not have a failed attempt from this file. Yeah. So I keep a list of every backup I take. And if I try to restore from a backup and I cannot do it, and it turns out it's because I couldn't read or the data in the file was not good, I mark it as failed. So I don't use it again. I keep it because I might still need it to like recover a single page or something to get some information out of it. So I'm not deleting it, but I'm marking it in my metadata as don't even bother. This one is broken. Yeah. So I find the closest full backup and thing is, if I don't find one, meaning there is no backups, then I fail. If I don't fail, I restore the full backup. I try to restore the full backup, which is fine. This might take a while, might be very quickly, and it's successful or not. If it's not successful, I check if it's a file issue. If it's a file issue, I mark it as failed. and go back and find the one before it by using the exact same algorithm. That also helps me to simplify my restore process because I don't have to like now have different code to go to the one before or the one before. The goal is no human being should be involved in the restore. So that piece of code has to do it all by itself. And you can do the whole thing in T-SQL. If it's not a file issue, I increase a retry count. And if I reach a certain retry count, I fail. Like after 3 times restoring something, this is like network blips or the target server has a problem where I want to restore to or something like this. It's at some point I have to give up. And I don't have to find a new backup if it's not a file issue. And I have a list of all the error messages that come back from SQL Server that gives you indication that the problem was actually with the data and not something else. So I can differentiate when I do a restore and get the error message back if it was an issue that I had a network blip or that the storage array did not actually send data. You can differentiate that in the error messages. It's not easy to get them out. You have to like manually sift through bytes in the input buffer, but you can get to the information. It's because the stupid backup command is nests 2 error messages, and the inner error message contains the actual error. The outer error message just says backup failed, which nobody cares. So you have to get the inner error message. But it's possible. Erland Sommarskog from Sweden wrote a procedure to get the inner error message, and you can easily adopt that. If the restore is successful, I reset the max retry count. So if for any reason I come back to do more full backups, and I mark the full backup as verified because I now know this one is good. I successfully and the way I verify it is I increase the count how many times I successfully restored from that file. So if I see even statistic that like I restored 5 times from this file because I did 3 development and 1 QA refresh already, the chances that I can do a emergency restore are way higher on this file than on anything else. And then I go to page 2. So page 2. I find the newest and closest diff backup for the full backup not marked failed. So now I'm searching for what is the closest diff backup to my point in time recovery that is based on that full backup. If I do not find a backup, I go to log restores because there might not be differential backups. Yeah, if it was just a full restore day and there's no differential yet, just move on. It's not an error. It's just there are no differentials. Or all of them are unusable. That's also possible. Thing is, if not, I restore the diff backup and basically the same handling as before. If it's not successful, is it a file issue? Then thing is, retries, all that. The difference is if I don't find a file, it's not an immediate error. It's just we don't have a differential backup, which might be a case. Either we didn't take any or we haven't taken one yet in that cycle. Yeah, and then the same thing. After I go here, I go to the next one, and now I need to find a list of log backups between the full /diff, whatever was the last one I restored, and the point in time that are not marked failed, and I order them by LSN and distance. LSN first and distance. Every backup has a start LSN, which is an always increasing number, so you can easily sort by it. The reason for that is I need them in order because I have now to restore them. Could I rely on file names? Yes. Should I do that? No, because clocks on machines are not guaranteed to be perfect. And if you have very fast cycles, and I've seen the clock on servers being off by a minute or two. And then if you took one log backup, one server, and the other one on the DR server, and they were off by 2 minutes, and then you suddenly have them in the wrong order. So I don't rely on file names. File names are great to have unique file names, stuff like this, but I don't for automated restores, I don't use. The thing is, I have the LSN number. I can get them easily for each file. It's an MSDB, or if you collect the data, it's in your central repository. Easy to find. But you get the list of all the log backups. Then I fetch the first log backup from that list. And basically, is the list empty? Could be that I have no log files. Either we don't take log files for the database, which is a possibility, or we haven't done one yet because the failure occurred right after the full backup was completed and there are no log backups, or they're all defect and we can't restore them anyway. Yeah? So if we reach the end of the list and there are no files, did we check the point in time that we want to reach? No, then it's a failure. If yes, then we are successfully restored to the point in time. So on the first one, that one is always a no, because it's not the same LSN as the previous one. So if I have multiple copies of the same log file backup, they will come in with the same LSN and then sorted by the distance. I get the closest one first. So that's usually the one in my own data center. And then the second one is like in the DR center. And then there's a third one in some steep, tucked away mountain somewhere. The third copy or something like this. Yeah. So did I already try to restore that? I could just try it and I would get an error message back, but it's faster to check the metadata and don't even try. So if like LSN 27 was successful, the next file is also for LSN 27, I don't have to restore it again. Yeah. So if it's a duplicate, just fetch the next one and move on. If it's not a duplicate, we restore the log backup with stop at the time that we want to do. And if it was successful, we reset the retry count and mark, oops, that should be log backup as verified. I will fix that. And we fetch the next one till we get to the point in time. Yeah, so very simple thing, fully automated. All it has to do is go through a list and work your way up. Find the thing is. The nice thing is, if at any point it fails, it will go back to the previous one and fix itself. So if the full backup doesn't work, it goes to the one before that and then tries to work its way down from there. If the diff backup, the last diff doesn't work, it tries to go to the one before and then works itself with the log files. I don't have to, once I'm at the log files, there's no point in going back because I already have the newest one that I could use from everything else. Yeah. So if I have a break in the log files, I cannot go back and try another way. There's only one way. So maintaining the log chain is super important. But that's pretty much it. The only thing that does not handle is one crazy thing. There is one case that this diagram does not handle, or this way of showing it handles. It's a super edge case. You have a failed full backup. That means you go back one earlier, and then you would do the last differential of that previous sequence. And then you would have to do the whole next area with log files, but that's not true. You can then restore a couple of log files till you are past taking the full backup, and then you can apply the differential backup of your broken full backup to that restore. Copilot, ChatGPT, and books online will tell you that it's not possible. Problem is, it is. It has to. The way restore works, it has to work because the differential bitmap gets reset, and that operation is a fully logged operation, so it's in the log file. So you don't need the full backup to do that reset of the differential backup. It also can be done through the log file. And I actually have a demo showing that where I delete both a log file and the differential one. So what that can help you if you actually automate that in is for the rare case where you have a full backup and then a log file, a log chain break in the same cycle. But you have a diff that goes through it. So you have to fix that. Yeah. I never came around to fully automate that. The fun part is it will get, it will fail actually to the point where in this case, it will fail. And then you only have to manually start it with skipping the full backups, the full restores, and then it will do the right thing. Uh, so it is possible to do it with the same workflow, but you have to manually tell it to ignore the full restore. So will I at one day fully automate that? Yes. How many times did this help someplace? Once in 30 years. Is it worth automating? Maybe yes. Yeah. Maybe if I have a week where I have nothing to do, that I write all the code with all the exception handling and everything and documenting it. I'm just mentioning it. That edge case that any AI will tell you it's not possible, and Microsoft support will tell you it's not possible. It is possible, but I have not yet automated it. Good. So let's go. Hello. Yes, unshare. So good. Now we have how we do the restores. Yeah? And automating this restore part is really important to get things done in a reasonable time. Could you do all this manually? Yes. Yeah, if you cleverly name your backup files, you can grab them and put them in something, put the restore commands around it, run them manually one by one. Problem is, if anything happens at 3 a.m. in the morning, your DBA needs to make a decision, and it probably will be the wrong decision. Yeah. Do you not want to not delete all the data not today? Yes, no. You have 10 seconds to give me an answer. Uh, how many negations did I have in the question? Yeah. And yes, I felt victim to one of these questions once. It was like 30 years ago, a RAID controller. I had a RAID 5. Back then, I didn't know better. 6 drives, and 3 of them failed because not the drives failed, but the cage they were in failed. So 3 failed together. And when the system came up, it asked me one of these double negation questions. And I gave the wrong answer, and the whole data was deleted. Uh, if I've not answered the question and just rebooted the system, everything would have been perfect. It was some freaking capacitor that was wrongly mounted on the cage, and it only happened when you freshly powered on the system, the very first time after a power loss, the cage did not come online. And when you install the system, you after you configure the BIOS, the system reboots, and therefore the cage comes online on the first time when you install it, and then you never notice it because nobody ever powers off the system after you put it a server. A server you plug in and never turn off. And yeah, yeah, that's was good. Took 6 or 7 days to recover all the data, but we did not lose a single byte of data because even if we lost the whole server. Anyway, so where was I? Double negation questions. So the next step, we now know we know what we need, the restores. We have a way to restore to that point in an automatic way. That we can kick off and it runs and it does all the retries and everything to the best possible. And it will notify because it fails. The failure, of course, is wrapped in some notification system that the DBA gets woken up. Because normally you want to kick off the restore and then not worry about it because usually the full backup takes a while. And yes, I can build a system where I can restore a terabyte in 7 seconds, but most systems will be way slower. So a couple of terabytes will be a couple of hours. And you don't want to sit in front of that. But the moment it's done, you don't want to waste time for the differential, and you don't want to waste time for the log file, especially the log files. If you have to restore like 200 log files in a row, you don't want to do this manual. And 200 log files in a row is not much. If you take a log backup every 5 minutes, that's 12 per hour. Uh, that's 200 per day. So even if you have to just do one day, that's 200 log files. Yeah. And that's nothing. I worked once in a system where we had about 500,000 log backups per day uh, on one database. It back then, and this was in 2008, it produced 5 GB of log per minute. And in 2008, there were no SSDs. So we had to write that to spinning disks. And yes, you can do it. Takes 72 spinning disks to do it. Yeah, you write one revolution per disk, and then you go to the next one. So you can write at the full speed because the slow part on a hard drive is the head that moves up and down. If you never move the head, they're actually pretty fast. 72 in a row, and you fit the whole log file on it. And by the way, each of the controllers for the 72 drives has 4 GB of memory that is battery backed. So we actually built an SSD. We just didn't know to patent it as that. We just thing is, yeah. Anyway, so now we have to come up with a backup plan. And in the backup plan, we have to define as A, how many backups we're taking. So how many full, how many differential, how many log backups. And then how many copies do we keep? And for a long time, there was a 3-2-1 rule that was used by many people, and it was a good rule. It basically says you keep 3 backups on 2 different physical media, and one is in a different physical location. Meaning one backup is in one data center, 2 backups are in the other data center. Since you already have them in 2 different data centers, they are on 2 different physical devices. So you can have the 2 backups in the same device. Technically, better is if you're on 2 different ones, but the other one is on the other side, and you keep 3 backups. That means you never overwrite a backup. You create a new one, and then you delete the first one. Okay? That was great till some idiot came to the brilliant idea that he could write ransomware that hijacks your machine, encrypts your data. And thing is, so this rule is not good enough anymore to prevent you from ransomware. For ransomware, you need the 32110 rule. You still need 3 backups on 2 different physical media, so that's the same as before. And one is in a different physical location. No change there. But in addition to them, one needs to be offline. So you need to have one backup. It could be one of the 3 or an additional 4th one. That's up to you how you implement it. But you need one that is not reachable through the network so that when ransomware hits you, it doesn't affect that backup. And the 0 at the end is the hardest part. It means 0 of the backups can have a defect. Because if you need the one that is offline, it has to be good. That means at least that one needs to be guaranteed to be good, but the other one should be good as well, because the offline is the problem is it will take you a long time to get to it, while the other ones are online. So they need all to be good. So you have to start verifying your backups. I'm good. I usually start sleeping again when I have 12 backups. I know I have 12 different backups lying around somewhere in different places, in different data centers, online, offline, maybe 1 or 2 in the cloud, stuff like this. I sleep well. Yeah. Sounds like a lot. The problem is storage is so cheap these days that 12 copies is nothing. And you want to have like 3-4 weeks anyway. So in 3-4 weeks, if you keep a month and you do a daily full backup, that's 31 copies to begin with. Yeah. Just take the Monday one in this data center and the Tuesday one in the other data center. Or take them both in the same data center, but then copy one over. Okay. So there's many ways of getting it to the other thing is, but you have to come up with that. And that brings us to placements of the backup. Where do you want to put them? And I start sharing again because that's, again, much easier to see than to thing. So, okay. So if you have two locations, put the first backup in the first location, second backup in the second location, third one in the first, fourth one here, and so on. I think that's the easiest case that everybody understands without a problem. You could do it in a different way. You have two locations. You take the first backup and you copy it to the second location. And then next day you take again the second backup and you copy it to the next location and so on. Third option is you take the first backup in the first location, copy it to the second, and then take the next backup in the second location and copy it to the first. So you flip-flop. So in this one, you're just alternating. Here, you're just copying. Here, you are alternating and copying. I like the last one. If I have only two locations, I like to do this. Why? The copy process always bears the risk that a couple of bits get flipped. So I like to have the original backups in either one of the data centers. And I mean also with availability groups, you can now take the backups, the full backups in either location. Yeah. So the next one is if you have three locations. And again, I always prefer three locations because one is none, two is one, and three is two. And I want redundancy. And the first number that you gives you redundancy is three, because if you maintain one of them, you still need redundancy. Otherwise, if you have only two and you maintain one of the two, you don't have redundancy. So three is, in my opinion, is the first one that gives you actual redundancy. Yeah? And it's much cheaper to have three locations than to have two locations with two servers on each, because that's actually four. Yeah. And these days, location number three could be the cloud. Yeah. You have two data centers and you put another copy into the location. I'm not saying you have to run there, but this is where you put the backups. Again, if I just do alternating, it's a simple case. Put the first one in the first data center, second, third, and then start rotating again. Yeah, fine. With copying, here it gets interesting. I take the backup in the first data center, copy it to the second data center, and from there, I copy it to the third data center. Would it be more efficient to copy both from the first data center at the same time? Yes, if you can afford reading it twice in the first data center at the same time. The problem is now you have to verify both backups to make sure that if you copy them all from the first data center, you have to verify two backups to know that they're all good. If you copy it from A to B and then from B to C and you verify the one in C, the other two must be good. Because if either one of them is broken, the third one is broken for sure. Yeah. So if you copy them in a chain, you only have to verify the last one to know that all three is. So if you ever successfully restore number C, you know that B and A are all good. That again, assuming that your storage is reliable and doesn't flip bits after you write the data. If you have storage that flips bit after you write the data, I can't help you. Do not use chisels in stone or something else, or write on with ink on paper or something to do your backups. Use digital stuff. Yes. It gets really funny, and I'm gonna share this document with you guys so you can go through this in detail. When you start alternating and copying with three locations, it's basically A, B, C, and then it's B, A, C, and so on, flipping back and forth. The idea is to always have a balanced number of files everywhere. So you want to have this many first files, this many second files, this many third files. Again, if you have to manage this as a human being, you go crazy, yeah, because you will make mistakes. But if you automate that, it will just work. It's a rule. It's just if I put it on Monday in A, then Tuesday goes to B. And if I copy on Monday this direction, then on Tuesday I copy this way. Yeah? So it's you define it once in a table and then you just use it over and over again in your automation. I didn't stop there. I stopped with two locations with two file storing locations. So you want to go in location A on the first filer, and then location 2 on the first filer, then in the first location on the second filer, and then the second location on the third. Copying here, again, is going to be funny, but still doable. But then when you copy and rotate, it gets really fancy. And as you can see, I go to 1, 2, 3, and then 4, and then copy back and forth. It's still doable, and a human brain can still comprehend that. It gets really funny in the next iteration when you have three locations with two storage filers on each. Again, the first one is pretty simple. You just rotate through them in a nice way. When you start copying, it gets interesting. It makes no sense to have 6 copies. Yeah, we still stick with 3 copies, but on the next day we use the other set, and then we go back to the first set and second set. Mixing up the sets, I did the math, makes no difference. Uh, it doesn't matter. It actually makes it less interesting because if you mix up the sets, you will have 2 consecutive copies next to each other on one, and then 2 consecutive on the other one. So no point in doing that. I guess. But if you start alternating and rotating through the 3 locations, then you get this. And I'm not even going to try to explain it, but it's the same. You start here, then you go here. On the next day, the third day, you go here. And here you notice I was on the first filer, and on the third day, I go to the second filer. If you have 3, you have to flip one of them. Because if not, you would get consecutive on the same filer again. So, but if you flip one of them in the other way, you can just rename it and could call this one A and this one B, but you have to either flip the copies or flip the original placement. From a coding perspective, when implementing it, I found it easier to flip the original copy because you can just have I basically don't care where the original copy is. If I have an original copy in a certain place, I need to copy it to these other places. How it got there, I don't care on which day. Yeah, so my code places the first one, and then I just call code that moves it to the other locations. Yeah, and it doesn't care how it got there and on which day it got there. It just knows if it's here, I need to move it over there. Yeah. Um, the interesting questions when you do these copy processes is how many days do you catch up if one of the filers fails? So one of the filers is for whatever reason not available, so you can't write to it. Okay, if it would be the one that gets the original copy on the day, you skip it and you just go to the next one. But then when you copy, if it's a copy target, do you also go to the next one? Or do you just not copy it there? And then when it's back online, do you basically queue the copy and do it at a point in time later? And how many days do you go back? Well, let's say this thing is broken for a whole week. Does it actually make sense to copy a 1-week-old backup over there? Yeah. Anyways, yeah. Um, Ideal solution would be I have 3 filers in each location and one is just a spare. Yeah. No way any budget will ever pay for that, but would be the solution for if I have a failed one. Again, if I already have like 3 copies every day, uh, and I don't have a copy on one of them, yeah, that's just the cost of doing business. That's why I have 3. So one of them can fail. And I will have one on the next day. Or I can define if I need to copy it to location B and one of the files is not available, then copy it to the other one. Yeah. Again, all things you can do, and it depends where you put your priority. You just have to define it. Once you define it, you automate it, and then you never think about it again. Because these things are super reliable. Copying files Humanity does it for about 60 years. We finally figured out how it works. It took many decades, but we can now copy files in a quick, reliable way from one location to another. We can verify that many things. We figured out that protocols need to change when the distance goes bigger, because you can have a 100 gigabit network connection between a point in the US and a point in Europe. You will be only possible to copy about 3 megabytes per second. Anything above 3 megabytes per second will not happen because based on the distance, you have a limit that network protocols will give you. If you take the file and splice it into 1,000 pieces and then send them all at the same time, each one goes with 3 megabytes per second and you have 3 gigabytes per second, which is about 30 gigabits per second, which is not a bad thing over a 100 gigabit link. So you can do that, and things like Robocopy can actually do that for you. As what? It's all there. So do we have more? No. So let's stop sharing this. No, I was too quick to stop sharing. So the last thing before we close for today is I will go through how I take the backups. Basically, I built the same diagrams as with the restore for the backups. Let me do that. Okay. So when I start my backups, I schedule them, and it's going to be a whole big part in one of the next sessions, how to schedule backups. But once it starts, I get what I call the backup plan, which is basically a table that I have that has all the options. Do I need to encrypt the backup? How many files do I split it into? Do I need to do full backup, log backup, whatever I need to do? It's a plan. What do I need to do is how to configure things like transfer size and buffer count and all these things that you can configure in a backup command. I have it in a table so you can set it, and you don't have to worry. And all the machines use the same thing. I usually have 2 or 3 different plans. For example, I have one backup plan for all system databases because I know I only have to take full backups there because everything else doesn't work. Yeah. So why bother trying anything else? Thing is, for regular databases, and then I have one for very important databases and stuff like this. Yeah. So it's basically I fetch my configuration and all the stuff that I need. Then I get a list of all the targets that I have. Yeah. And the backup plan tells me which targets to use and in which order. So it would tell me today I go to this filer. If I would call the same procedure tomorrow, the backup plan would tell me, no, no, today we're not going to this filer, we're going to the other one. Yeah. So this is what part of the backup plan and the list of targets. The list of targets also knows how far the filers are away. And again, with far, I mean how much throughput on the network link are they away from me. Yeah? So again, big pipe to a faraway target might be listed as nearer than a small pipe to a close by location. And the reason we need multiple targets is the backup code that I use. If it fails, and it's the reason, for example, is that my target is full, then there's no point in retrying to back it up again because it's probably going to be full again. But if I go to the next filer, hey, it might be empty. And I can put it there. Yeah. And so, for example, what I do is I have like, as a last resort, I have always one filer where there should be no backups on it. So if all the other ones are full, this is like my overflow. It goes there. Yeah. Is it the fastest? No, but it's at least it's there. Yeah. So let's get the thing. The first thing is I check, can this instance actually take backups? Or is it configured to take backups today? Yeah. Because what I do is I issue that backup procedure to every replica of my database. So if I have an AG with 6 replicas, this runs on each one of them and then figures out, is this the one I have to take backups of today? And if it's so, then it does. If not, it says, no, I'm done. Yeah. And therefore, I don't have these stupid errors in my agent that tells me every day, hey, that backup failed here. Yes, because you are the non-readable replica and you cannot take backups. Uh, but if you would become the primary, you should take backups. And I hate the error messages, and therefore I have this check in my backup procedure, and that exits still cleanly. It will log that it tried to do that and not have. And then I have thing that collects all the logs. And if all 6 of my replicas report, hey, we didn't do backups today because we were not configured, I know that I made a mistake and configured something wrong. So it's still there's checks and balances in there, but the thing is, yeah. So the first thing is it figures out, is it a log backup? Is it the differential backup? If it's a log backup, go do log backups. If it's a differential backup, go do differential backup. And if it's neither one of them, it has to be a full backup. I do not deal with file group backups. If you want to do file group backups, I commend your bravery. You're on your own. Uh, I've tried it. It makes no sense. Yes. Can it help you with a petabyte sized data warehouse where you have data that hasn't changed in 5 years? Yes. Problem is, data changes even if it doesn't change because the structure of the data changes, and therefore the structure of the read-only parts will change, and then you have to take the backups again and again and again. Yeah. And the problem is the database is in read-only because file group backups only work on read-only file groups. And therefore, every time someone wants to change something, you have to take it out of read-only mode. And the problem is taking it out of read-only mode is an offline operation. That's how you have to take offline your database every time you want to change the structure of a database. If you have a big data warehouse, there's a couple of thousand tables in it. I guarantee you at least one of these tables changes every day. Yeah, because otherwise, yeah, there's no case where it works. If you have a case, please let me know. I'm happy to observe that, but I have not found one. So let's see how log backups are done. Um, the first question the procedure checks is, can I take a log backup? So for example, if your database is in simple mode, no, you can't. Or if your database is a system database or something like this, no, you can't take a log backup. Won't let you. So let's not even try it and bail out successful again. Of course, I log that this happened because your backup plan should not call for a log backup if you can't do a log backup. But I rather error out on the default, and the default plan does everything. So if you have add a new database and it doesn't have a plan assigned to it, it uses the default plan that tries everything, and then it cleanly bails out for all the things it cannot do. Yeah. So if you ask for a log backup, it cannot do it, I'm done. The next one it checks is the log chain broken. So it checks the last backups it took and figures out if the new backup would be a correct follow up to the log chain. If it's not, and you can get that out of the metadata in MSDB. It is a little bit tricky if you have a failover to the secondary because now your MSDBs don't line up. So if you notice that you had a failover, which you also can check in your metadata, if you had a failover since the last full backup, you have to go to your primary instance and read it from there. This gets a little bit complicated, but again, it's worth the checking because if you have a break in your log chain, I changed the log backup to a differential backup and say, I'm out of here. A log backup makes no sense because the blockchain was broken and that log backup could never be applied to anything. So I'm not taking it, but I'm forcing a differential backup to be able to fix the log chain. Then I prepare my log backup command. This should be log, never use copy paste, and execute the log backup. If the backup is okay, I go to the post cleanup stuff. If not, is it a space issue? If yes, then are there more targets available? and then switch to the next target and try the command again. And again, this should be log, not diff. If it's not a space issue, then we have a retry count and we try it again till we either fail or succeed. Yeah, so this is the log backups. For the diff backups, it's very same. First of all, I check if I can take a diff backup. When can I not take a diff backup? If I don't have a full backup yet. If the database was never backed up, I cannot take a diff backup before I have a full backup. And again, this is for the default backup plan that says take everything. If I create a database in the middle of the week, there is no full backup because that's probably only done on the weekend. So instead of not taking a backup for the whole week or failing the differential backups for the whole week and not having backups, I rather figure it out and change to a full backup. Yeah. So that's what I do when I try to take a diff and I can't take a diff. Second case where this happens is if you try to take a diff on master, it says you can't take a diff backup. Master can only take full backups. You end up here too. The next check I do is the last differential backup larger than 30% of my full backup? So was there a previous diff backup in that sequence? And is it more than 30% of the full backup? Because once a diff backup reaches 30% of the full, there's no point. It's not a shortcut anymore. It's not helping you. Yeah. So what I do is I change it to a full backup to have a clean new start. Thing is, you can adjust that or put that in a configuration. That's also possible that you say, hey, in some databases, once you reach 10%, I don't want to diff backups anymore, or you say it's 80%. Whatever works for you. I just recommend doing that because otherwise, I had once a database. What they did is twice a day, they deleted all the data and reloaded it. So if you took full and differential backups, you on day one, the differential backup was 100% the same size as the full backup because all the data was new. Yeah. And then the next day it was again and again and again. Yeah. And not even to speak that the log files in between had the whole data in it again. So we changed that database to not use log backups anymore and not use differential backups and not use full backups because since they delete all the data every day, all we kept was an empty database backup. We back up the database when it was empty because that's the starting point. If they have any problem, give them the empty database and start your process that you run twice a day. Yeah. So, and this was a feature how we detected this. Yeah, that this database was actually doing a stupid thing. By the way, also the only database I ever encountered that killed the wear level on an SSD. They basically had 4 full writes per day on the database on the disks. And the wear level was only 3 drive writes per day. So within 5 years, they killed an SSD in a real production environment. Good job. Then I prepared the log backup command. This should be the diff backup command. Sorry. I think my copy paste and editing, I was in the wrong page. So this is diff backup command. Execute the backup. If it's okay, go to the end. If it's a space issue, try the next place. And if it's not a space issue, try a couple of times and then stop. With a couple of times, I usually define it as 3 times. So the first one, the second one, and the third one I bail out. If your network is that unstable, fix it. If you keep rebooting your servers while you're taking backups, change your schedule. Um, Again, I don't have a problem with failed backups if I can figure out why. And all these things, every one of these steps logs what they're doing. Yeah. So if I look, how is this broken? I have the whole history, what happened and what didn't happen. Yeah. So usually after observing 1 or 2 days of these failures, I can figure out what is the problem. And again, reboots of servers while they're doing backups, not an uncommon thing. Uh, Running out of disk space, not an uncommon thing. Network blips are rare. If they happen, change the components because it's not necessary anymore. Network equipment is pretty stable these days. Yeah, so that's a differential one. Let's have a look at the full. The full is the simplest one. You prepare the full command, you execute the backup, there are no checks. Full must always work. There's nothing that can stop you from taking a full backup because we already checked if the instance is ready. That happened at the very beginning. The backup okay, go to the end. If not, did we run out of space? Do you have more possible spaces where I can put it? If yes, just start at the beginning. If not, retry without rewriting the command. And if not, you fail. What do I do at the end? At the end, I do something very simple. I haven't mentioned this before. While I'm taking a backup, I call them .wrk for work, about three-letter word for work. Um, and the reason for that is so that if I have stupid processes that go for the file name, they don't try to do something to my file before I'm done. So, for example, if I have some stupid script from the storage team that tries to scrape it and copy it to like the backup site or something that scrapes for all the new files that are called .back, they might scrape it while I'm still taking the backup and then copy a half backup file, which makes no sense. So I call them .work, and once it's done, I rename them to .back. Unfortunately, rename fails occasionally. It's hilarious. A good tip is wait about 5 to 10 seconds after taking the backup before even trying to rename it, because apparently once the backup is done, it's not really done. Because you can't rename the file before the Windows memory buffers haven't flushed completely to disk or something like this. Yeah. So again, for the rename, I have a retry count. I think I tried like 20 times because this is really annoying to fix manually. So I try a lot and I keep like the first time I wait 5 seconds and every time I add another 5 seconds to wait. So the second one, 10, 15 before I try to do the rename again. Problem is if you have like 64 files, that can take a while to fail. But on the other hand, if I don't have to manually fix the names just because I didn't wait long enough, I've never seen take I, the thing where it's still in the Windows buffer. I've never seen that not succeed with, I think, a retry count of 20 with 5 seconds in between. The thing is. And then I queue copy tasks if I do the copying. If I'm responsible for copying to other places, I just write into a table, these things need to be copied, and then some other process picks it up from there. But I'm saying, I'm now done. Now you can start copying. Yeah. I'm not relying on something else to pull all the time. Can I copy? Can I copy? Can I copy? I'm like, no, I write you, I'm done. You can continue. And then I update my configuration database that this backup is completed. It's and that basically tells it with the copy tasks. At the end of the copy tasks, they will then schedule the verifies. Or the update in the CMDB could trigger a case where I immediately start a restore. If I have to, example, after my full backup, I have to refresh my test environment or something like this. I don't want to wait for the copy. I do the restore while it's copying. Um, or it might be that I copy it to the DR side because the dev environment is also hosted on the DR side, and then I wait for the copy and then I restore there because it makes no sense to move the data twice. Yeah, so that's my copy process, and that's the plan for doing it. This is not revolutionary new. This is pretty much what everybody else does. It just wrapped into an automation to ensure that everything does and that it works around the most common issues. Because what are the most common issues with a backup? It fails because it runs out of space. My guess is 99% of all backup failures is because something failed. The second reason is because something got rebooted or disconnected or restarted or something. Why? because we're doing like large full backups on the weekend. And when do we do maintenance and when do we do patching? Also on the weekend. And it's amazing. We humans have the capability to talk to each other, but you would be surprised the more humans you put into a building or a big enterprise, how hard it is for them to talk to each other. Yeah. And schedule that the guy who patches your SQL instance is not doing it while you're taking full backups or maintaining indexes or something like this. Final remark, continue restore on failover. I cannot remember having a backup failed because I failed over an AG. Uh, because automatic failover happens during business hours because I stress the system and something fails. They don't happen when on the weekends when the system is not doing anything. And I don't patch my or fail over manually my systems while I'm taking backups because I'm a DBA that checks things like this before doing it. So I don't see the big thing on the resume backup. It makes backups measurable slower. We're talking percentages. It on a small backup, it's insane. It's like 3 or 4 times the time. On large backups, it's like 2 or 3% more. But that adds up. In time when all you don't forget another thing you have to figure out is how many backups can you do at the same time on a machine. Can I do one or can I have like 100 databases on a machine? I can guarantee you cannot do 100 backups at the same time. People tried. uh it was easy in the early days of log shipping. It was like the DBAs were, yeah, configure log shipping, next. And then all the log shippers happened, all the tasks were happening at the exact same time. So if you try to start 100 backups at the same time, they will not succeed. Uh, the the backup command cannot obtain a log quick enough on the metadata in MSDB to actually start the backup. So you have locking issues in MSDB, which is hilarious. Uh, Thing is, but if you stagger them and like wait a minute between the backups, you can run 100 backups at the same time. Just don't expect the server to do anything else, especially if you compress the backups, because your CPU will be at 100% till you're done with all the backups. Theoretically, SQL is supposed to back down from backups CPU-wise when real queries come along. Problem is if you have 100 backups, 100 tasks need to back down. Till they all finally back down, the original task that was waiting for a schedule gave up already. But doing 5, 6 at the same time, no problem. Doing 100 log backups at the same time, absolutely not a problem. Again, if you stagger them. If you start 100 at the same time, it's not. But it's a thing. Good. I think I've covered what I wanted to discuss in part one. I hope some people are still awake, or uh, when you watch this later. We will continue in about a month with part two, where we go from here and look at how to deal with exceptions, and then in part three also look how to implement this in automation. And I will actually show you the code that does all that stuff, which is not that more. The nice thing is if you start with these diagrams and go through them and use them to code everything, it's not that crazy. No, yeah. And next time, I was planning on actually doing it today, but we're already like 2.5 hours in. So the the part is how you actually build a backup filer that it is that fast. We will start with that next time. So we've now covered the software part, and then the next time we will start with building a backup filer, and you will be surprised. You have like one more minute, I can give you a sneak peek preview. This is
Absolutely.
how a backup filer should look like. This is the small one, by the way. This one can store 60 hard drives, 30 terabytes each. This one can do 90. They only pulled it out half to take the picture. There's another 45 in the back, 90 drives in one 5U, 4U case. They are from reputable vendors. So this half of AWS runs on this vendor. So these guys are good. And to give you an idea, with 32 terabyte hard drives, if you use all 90 drives, you get 2 petabytes per server on usable capacity. That includes 6 spare drives and 12 parity drives. Yeah, so technically the raw capacity is much higher, but this is what you have. So 2 petabytes, and this is bytes. This is not storage bytes. This is actual bytes. So this 32 terabyte is storage bytes, but this is actual bytes. So when you go in File Explorer, it says that many gigabytes. And yeah, so how fast are network interfaces? 10 gigabits is 4 terabytes an hour. You can, in a 10 gigabit interface. If you have 400 gigabit network cards in your server, you can do half a petabyte per hour. Yeah. So this is how you get to reasonable. This is how you get to 7 seconds per terabyte. Is this unreasonable today? No. This is not. This is which PCI interfaces you need. You couldn't do this 5 years ago because PCI was still on 3. PCI 5, you need 4 slots, and you have 10 slots in a server. So that's not a thing. And for 400 gig interfaces for an enterprise, it's not a cost factor.
No, put it this way. I was looking at a 4-port 400 gig switch for my house, and
Yeah.
Microtech makes one for 1400 US.
Mhm. Yeah. So how much can you write to the disks? This is the interesting part. If you have 90 disks or 6 sets of 15 each, you can do sustained writes. That means you don't stop with 25 terabytes per hour on spinning disks. Yeah. You can reach a peak performance of 62 terabytes for about 30 minutes. After 30 minutes, this is over. The tricky part is when you have the only thing that you store on your filer is SQL backups. You can enable write caches on the disks. You cannot do this in any other configuration. If you do this in any other configuration, you will end up with corrupt data. SQL backups have one awesome feature. They are either complete or not. If for any reason they fail in between or the storage thing fails, they're not complete. Who cares? It's an incomplete backup. I'm not going to use anything like this. If you do this to your normal data file and portions of it get invalid, you can't use that. But for a backup file, it either works or it doesn't. So if the write cache either works or doesn't, yeah. So it's the thing you can, and that gives you an enormous boost. That makes the freaking thing almost twice as fast. Yeah. The problem is at some point you exhaust the write cache, and even the write cache cannot keep up. Also, drives on the outside are faster than on the inside. So the more you fill up the storage thing, the slower it gets, stuff like this. And this is how many network cards it is. To get to 25 terabytes sustained or 62 terabytes per hour, you only need 200 gigabit Ethernet. That's not that much. So putting 200 gigabit Ethernet cards in one of these servers is not that bad. You remember before we had much more. Yeah? So one of these filers, they're super dirt cheap. And thing is, depending on the disk size, this is how long it takes to read the whole filer. So if you have 32 terabyte disks in there, it needs 78 hours to read the whole filer, 90 drives, which is basically 4 days. Yeah. So you know that every 4 days you can actually fill up that thing. And this is, should you have just one of these? No. If you need one with 90 drives, I much more recommend to you to have two with 45. So you can alternate them. And if one fails, you still have the other one, stuff like this. Yeah. But a big enterprise would probably have 6 to 20 of them in each location. And then performance is not an issue because let's say if you have 10, let's say you have 12 in each location. You take a backup with 12 files and you write each file to a different filer. And you have an enormous speed. So that's the preview. This is how this thing is configured. And the thing is, and to go really crazy, I can build what I call a landing zone. That's an SSD-based server. It's not for long-term or short-term storage. It's just to dump the backup and then you take it from there. And what you can do there, you take Kioxia, that's the new name for Intel when it comes to SSDs. It's all Intel SSDs. Kioxia just bought everything from Intel, including the employees, and is making them now. They are really good. They have drives that are about 12 terabytes in size, and they can write 11 gigabytes per second. Um, or you take the not CM9s, you take the CD9s, which have 60 terabytes per drive. Don't ask about the price. But they can only write 7 gigabytes per second. And with the first one gives you 720 terabytes per hour. That is more than you can get over 400 gig network cards. So you're good. So the network is now your new bottleneck, as it was for many decades. Problem is you only have 200 terabytes capacity, so you can only fill it for like half an hour. Then it's full, which also means it's really fast. Imagine you have 64 of them and you split your backup into 64 of them, how fast you can go back up there. Problem is, even the HP Superdome that has over 200 network PCI slots cannot produce data fast enough to fill the need of 64 of these. So it's just a theoretical thing. If they ever build a next generation of the Superdome that has the latest PCI Express buses, that's a different story. Then Microsoft finally has a reason to go above 64 files. So, but again, this is crazy thing. This is how this looks like for 400 gigabit network cards, little CPU, and then 20 NVMe drives. And again, that's not a big, that's by the way, a 1U machine. But again, I would not use this. The price tag of this thing is insane, especially today with the shortage of everything that involves any form of silicon that stores something. Because it's no longer just memory, it's now also the thing. Um, yeah, so this is a little preview. We'll go in more detail and how to calculate all this to figure out how much you actually need, because this is nice. This is the top end you can build. And then you take away everything you can't afford, and then you see what you need. Good. I stop sharing because if I don't stop sharing, I don't stop talking.
I don't know about you all, but I think I could use a nap now.
Yep, me too.
Brain,
But
brain is officially full.
yeah,
So we will pick this up in a month with part two. So be prepared for your brains to explode yet again, and we will see you next month.
Thanks, TG. Thanks, David.
yeah.
Yep. Thanks, guys.